Cranberries, blueberries, cloudberries, sedges, bushes, and lichen have long covered the tundra in the western Canadian Arctic. These plants have given grizzly bears, caribou, and other wildlife an abundance of food. But portions of that terrain are now being reduced to mud, silt, and peat as permafrost thaws and slumps, releasing enormous amounts of carbon that has been stored in the permafrost for millennia and contributing to global warming. Dozens of buildings would have been destroyed if this had occurred in a city. An environmental catastrophe may have occurred if it had occurred along a pipeline right of way. The speedy melting of Arctic sea ice has garnered the majority of public attention as the Arctic warms more quickly than any other area on Earth. However, there are also significant changes occurring on land, the most notable of which is the thawing of large areas of permafrost that have been beneath these polar regions for thousands of years. Scientists like Marsh are now stepping up their efforts to understand how these changes will unfold this century and beyond, as the thaw is having an impact in intricate ways that are yet poorly understood. What is known is that there could be severe repercussions if the Arctic warms as fast as climatologists anticipate. An estimated 2.5 million square miles, or 40% of the world's total of permafrost, could vanish by the end of the century. The release of massive greenhouse gas storage facilities, which have been trapped in the permafrost for eons, is anticipated to be the most concerning. These stores include methane, carbon dioxide, and nitrous oxide. It will also discharge pathogens. The drastic changes to the landscape that will affect tundra ecosystems, however, are less commonly recognized. These changes will make it harder for Arctic animals and indigenous people who depend on subsistence hunting to get food, like the Inuit. The subsurface ice that holds the peat, rocks, sand, and other inorganic minerals together is now breaking down at alarming rates, causing landslides and slumping. This is causing stream flows to change, lakes to suddenly empty, seashores to collapse, and water chemistry to change in ways that may be harmful to people and wildlife. Marsh, a hydrology professor at Wilfrid Laurier University in Ontario, and a former Canadian government scientist, claims that he has observed slumping along shorelines that have the potential to drain most of a lake's water in a matter of days or even hours. Given that up to 80% of this area's surface is covered in frozen water, this is hardly shocking. The frozen earth practically collapses when the ice melts. Marsh claims that as a result, the government, resource business, and indigenous people must all have a better understanding of how warming temperatures are affecting permafrost ecosystems and water supplies. Marsh has already come to the conclusion that this century's hydrological changes brought on by climate change will cause 15,000 of the 45,000 lakes in the Mackenzie River Delta, one of the world's largest deltas, to dry up. His studies in the Canadian Arctic supported this conclusion. He anticipates seeing more of what farther north on Banks Island in Canada's high Arctic, geographer and permafrost specialist Antoni Lukovic of the University of Ottawa sees. According to Lukovic's new paper, sinking along 288 lakes he tracked using satellite photos between 1984 and 2015 increased 60 times. Slumping can happen with an unexpectedly powerful force. In one famous instance, a fast thawing cliff that was adjacent the shores of a tundra lake crashed into the Peel River watershed in the Northwest Territories in 2015. Steve Kokolj, a permafrost specialist with the Northwest Territories Geological Survey, was able to capture the event on time-lapse photography. In just 2 hours, the cascade that was produced emptied that Highland Lake of almost 800,000 gallons of water. The river system was contaminated for miles downstream by heavy metals like mercury that were washed downstream with silt and peat from the permafrost. Permafrost is found in places where the ground temperature stays below freezing for a minimum of 2 years. This describes about 25% of the land area in the Northern Hemisphere. Northern Russia, Canada, Alaska, Iceland, and Scandinavia are home to the majority of the world's permafrost. Peat ecosystems are mostly supported by it. However, similar to peat, permafrost can also be found in the high country of New Zealand, the Alps, the Himalayas, the high-altitude Patagonia region of South America, and the Rocky Mountains of Canada and Alaska. There are significant consequences for climate change from the quick thawing of permafrost. One of the world's greatest carbon sinks is the Arctic, where an estimated 1,400 gigatons of carbon are trapped in permafrost. This represents about double the amount of emissions already in the atmosphere, and about 4 times the amount that humans have released since the Industrial Revolution. A new study estimates that by 2100, Over 40% of the world's permafrost will have disappeared due to a 3.6 degree Fahrenheit, 2 degrees Celsius increase in temperature that is predicted by the end of the century. On the tundra, there are two ways that greenhouse gases are emitted. A process known as permafrost thawing releases carbon and methane into the atmosphere as hibernating microbes break down organic debris. Methane may also rise from subterranean reserves through channels made accessible by thawing. The Arctic is seeing an increase in the permafrost thawing that is causing the release of greenhouse gases. According to Lukovic, a significant portion of the permafrost deterioration that has happened on Banks Island, Canada, occurred following some of the warmest years ever recorded. 60 slumps were active on the island in 1984. It numbered 4,000 by 2013. It is anticipated by Lukovic that in the upcoming years, the island could witness up to 30,000 new active slumps. Lake and stream chemistry and flow, as well as the regions of the Arctic Ocean into which rivers empties, will be significantly impacted by this thawing. A few of the lakes on Banks Island, for instance, have turned from blue to turquoise in Lukovic's satellite data, suggesting that the once clear water has now filled with sediments. Because of the slumping, scientists believe that several viruses that kill caribou, nesting birds, and muskoxen may be reviving because of the rising temperatures that are forcing them out of dormancy. Deadly infections that were dormant but are now reviving appear to be connected to the massive die-offs of muskoxen on Canada's Banks and Victoria Islands and reindeer in Siberia. Hundreds of sump pumps that were dug up by the oil and gas sector in the 1970s and 1980s are already thawing, according to scientific findings. In the Mackenzie Delta, for instance, toxic petroleum waste that was intended to be permanently trapped in 200 frozen pits is now moving into adjacent freshwater environments. Hydrologist Oliver Sonnentag of the University of Montreal and postdoctoral geography researcher Carolina Voigt are measuring how climate change impacts greenhouse gas activity on the tundra at Trail Valley Creek using both manual and automatic sensors. As a PhD candidate in geography at Wilfrid Laurier University, Evan Wilcox has made significant discoveries regarding the influence that warming temperatures are having on the rapid growth of shrubs in the Arctic, which is thawing permafrost. Sedges, grasses, and lichens that previously dominated tundra are giving way to shrubs as the Arctic warms. The bigger bushes are altering the hydrology of the ecosystem in addition to shading out the smaller plants below. The rate at which the active layer permafrost thaws is largely dependent on the date that the snow melts, according to Wilcox. In areas of the tundra with dwarf birch plants, snow usually melts 1 week sooner than in places without shrubs. More permafrost thaws as a consequence. We're going to witness an acceleration of thawing as the shrubs spread into the tundra. To find the depths of ground thaw, Wilcox drills steel probes into the ground. One summer, he drilled as many as 3,000 of them. Even though it is an intense endeavor, Niels Weiss, a postdoctoral researcher collaborating with Marsh, finds it considerably more difficult to pound through the solid ice and obtain the sample required to ascertain the quantity and type of organic material present in the permafrost. Weiss and colleagues have studied permafrost in Siberia, Scandinavia, and Canada. They have discovered that various factors, including soil composition, groundwater flow, and the predominance of trees, shrubs, or grasses, influence carbon storage and the mechanisms by which gas is released from these ecosystems. He asserts that it is evident that permafrost is thawing more quickly even in the Arctic's hottest regions. While there is still much to learn about the effects of thawing permafrost in the area, according to Marsh, one thing is becoming more and more obvious. The tundra environment will look very different in the next decades than it does now. As we hiked through 8-foot tall willows to recover a water gauge that was washed away during the spring flood, we could clearly see that change. This terrain was dominated 30 years ago by sedges and lichens. Willows and shrubs are spreading over the tundra now. Lichen used to be a common food source for caribou, which reached 3,000 individuals on the Tuktoyaktuk Peninsula in 2006. There are now only half of those left. How can we prevent the formation of even more megaslumps? Reducing the quantity of greenhouse gases discharged into the atmosphere while sequestering carbon dioxide is our best course of action. We had better figure out a technique to refreeze the Arctic before it's too late if we don't succeed in doing this. As David Suzuki says, pollution and climate change by excessive burning of fossil fuels are real threats, not the people who warn that we must take these threats seriously. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more, and be updated on the latest news about natural calamities or disasters happening all over the world. and don't forget to like today's video. We'll see you in the next video. Thanks for watching.